Hi everyone. In this video, I will be covering what is Helm, why do we use Helm, and some of the Helm concepts like chart, release, and repository. So Helm is basically a package manager for deploying application to Kubernetes. We usually have package manager like yum, apt-get, which is used to deploy packages, system packages on Linux. Similarly, we have Helm, which deploys application on Kubernetes. So Helm deploys application using Helm charts, which is usually a bundle of YAML templates. So by YAML templates, I mean the Kubernetes objects, which are deployment, service, config map, ingress, service accounts, network policies, and various other components. So these all components YAMLs are bundled together, which forms a Helm chart, and then the application is deployed based on some customization. So these customization might be different for a dev account or a prod account or a UAT account. So for example, if you're trying to deploy Argo CD, you might be deploying only one replica of each of the Argo CD components like controller, repo server, or any other components in the lower environment because you might not be looking for a high availability and you want to save cost. But in the production environment, you might be looking for more than one replicas for each of this component or stateful sets so that it is highly available and Argo CD is accessible all the time. So that is the reason you might require customization and doing that customization from a native way of deploying it using YAMLs is slightly challenging. So if you think from the Helm chart perspective, it is easy because you can just update the replica number or count in the values.yaml of the Helm chart, and then it can be deployed easily. So let me show you how the Helm chart structure is. So I have a Argo CD Helm chart here. So Helm chart usually consists of chart.yaml, which has the information of like what application it is, what version of application it is, who is maintaining the application, a description of it, and if that particular Helm chart is dependent on any other Helm chart, then that information resides in chart.yaml. Then we have values.yaml. So this values.yaml is actually used to pass the custom values, which is taken into consideration by a release, by a Helm chart release when the actual release happens. So, for example, if you want to install CRD. You can just put the value as true when you're installing Argo CD. If you don't want to install the CRDs of Argo CD, you can just put it as false. So you don't need to search for that particular place in the YAML where you actually want to put this value. So instead of that, you just pass it in the values.yaml and Helm chart release takes care of it. And then there's a template folder, and template folder has all the YAML of the Kubernetes object, which is actually required for the release, or which is actually required for some kind of release. So for some particular scenario of that application deployment. So for example, if you want to deploy an application which is not having cluster role binding into consideration, you are just giving a full permission and deploying it. In that case, you might not be using some of the YAMLs and might be deploying other YAMLs. So all those YAMLs are residing inside templates. And then we have a chart folder here. This is there because we have a dependency of Redis HA helm chart for Argo CD, which is actually shown in the chart.yaml if you see. So if I talk about this chart as a standalone chart, the Redis HA, you see that, okay, we have chart.yaml for Redis HA chart. We have values.yaml for this Redis HA chart. And then we have templates. Inside these templates, we have all the YAMLs which are used by the Redis HA deployment if it is enabled. So if you look into this chart.yaml, it says that if Redis HA is enabled, then particularly this Helm chart will be used. This particular charts folder will come into picture. Otherwise, it will be lying inside, but will not be used while you're doing a release. So this is how the structure of a particular Helm chart looks like. Now coming back to why do we use Helm charts? So suppose if you want to deploy Argo CD, and if you're deploying it Argo CD using YAML. So YAML might be very big. So if you look at this YAML, this is, I think, a particular stateful set, which is there for Argo CD repo server. It's a deployment for Argo CD repo server. Now, if you want to modify any value, if you want to modify the Argo CD repo server format, possibly it would be challenging as you need to search this particular YAML in this long YAML, this configuration, this long YAML, and then it would be becoming challenging. So that is the reason we have Helm charts into picture, which is usually a native way of deploying uh, Kubernetes application or application into Kubernetes in the industry wide. So now coming uh, to Helm charts use, it is helpful because it provides versioning and it has a rollback support. Now if I show you, I have a Helm chart deployed into my cluster right now. If I do Helm list -a, once- so -a is like for all namespaces. So I have one particular Helm chart deployed, which is Argo CD, and it is of revision 1. So now you see ctl get -n Argo CD. So all the pods are up and running for Argo CD because of this deployment. And now, if I want to increase the number of replicas for the application controller from 0 to 1, there would be a change in the Argo CD values.yaml, and then a redeployment would happen, or a release of Argo CD Helm chart would happen, and then there would be revision too. So it's easy to maintain the revision. You can get all the information, what Argo CD Helm chart is deployed, what is the app version of the Helm chart, when it was deployed, and what is the difference between the last version and the current version. It is easy to have an audit of the deployment or the release which is happening. And it's easy to configure the deployments. This we have already seen, like, so if you go here and if you want to update anything in values.yaml, it's easy to update into values.yaml so that when the release happens, it automatically picks up. And then uh, it's it's easy to maintain. There's a huge community for the Helm charts which are open source for Argo CD, Grafana. The charts are maintained by community. There are various vendors who are maintaining those Helm charts which are publicly available. So you don't have an overhead of maintaining those Helm charts at your end. You can just use those Helm charts and deploy the application directly. Now let's talk about some of the Helm concepts. Chart, we have already seen this. Helm chart is a package bundle which is used to deploy application to Kubernetes. And then if you talk about release, we have also seen this that whenever we deploy a Helm chart is actually a release and which can be seen from here. So this is one release which has happened. Now the third concept is repository. So we have Docker Hub for storing the Docker images. Similarly, we have repository for storing the Helm charts. There are various solutions available in market like JFrog, Nexus, Chart Museum, which is an open source solution. And then you can also publish your Helm charts on GitHub. So let me show you. So I have Helm repo ls. So I have added these three repositories into my local. One is Argo, one is GetStack, and one is CodeCentric. So we can see that these two repositories are hosted on GitHub. Now, if I do Helm search repo, and if I do Argo, okay, I can see so many application Helm charts are actually part of this Argo repository, and these all are maintained by Argo CD, Argo community. So, which includes Argo CD, Argo CI, Argo events. Now, if you want to see what all versions of Argo CD releases are there, so in that case, you can do Helm search repo Argo /Argo CD hyphen versions. So you can see all the versions are maintained. So it's a publicly available repositories. The Helm chart is publicly available. So now suppose you deployed a particular version of Helm chart, and after a year the deployment went down and you want to redeploy. The Helm chart would be publicly available. You don't need to maintain at your end. You can just deploy the Helm chart uh, again on the cluster. So this way it's easy with the Helm charts to deploy an application into Argo 3D into a Kubernetes cluster. This is all I wanted to cover in this video. I will be adding more topics in the upcoming videos related to Helm and Helm charts. Thanks for watching.